All right. Uh, Wonderful to be here. Want to start with thanking Chicago Innovate Tech, and a great note to start on after talking about altruism. Um, I'm going to start by introducing ourselves. My name is Yash Mehta. Um, I'm an architect here at Lamar Johnson Collaborative in Clayco. And my colleague, Bruno Silva, who's also an architect at Workshop. And I want to single out, sorry for the spotlight, Taruna Gupta. We run a nonprofit together, and that is what we want to represent today. Um, we want to talk about sharing with you a big group, a community, or a diverse family that we are a part of, calling ourselves Defining Humanity, people from different walks of life and expertise, from being a lawyer to someone who's working at Google to someone who's working at NVIDIA, and how we all come together and try to find out solutions. And because of this diversity, we get 30 different perspectives from 30 different members, and our potlucks are amazing. And we swear in different languages, but we come together for a single cause. And we have a lot of initiatives going on, right from trying to find solutions for affordable housing or homelessness or building a bomb shelter in Ukraine and so on. Today, we want to discuss and talk about a project which is specific to this crowd. Um, it is a project that two projects actually. It's a school that we've 3D printed in Africa where we don't speak the common language. There is a time difference. There is no electricity on the site. There is no plumbing on the site. And yet, uh, we are able to deliver a school in less than a day. Uh, Diving a little bit into the technology, 3D printing is not a new technology. The first patent to 3D print was 1941, before any of us were born, hopefully, in the room. Uh, and it was as simple as someone pouring material and a manual person just moving the sort of the output in a circular fashion, all the way through innovation today, where you're printing on Mars and exploring uh, ecology, the Martian ecology, and understanding those aspects, and that we cannot send human beings there. And how can we send machines who can set these things up? And the reason I'm proud and humbled to speak as a nonprofit today is because we somewhere lie in between printing things on Mars and, how can we use technology is only as good as the question we ask it. And I think that is super important to know that it's a loaded gun, and whether you're on this side or that side, right? So uh, we came together with all these 30 people and made a framework for ourselves that we operate in, and we'll show you how that we can execute these things in a project. The four cornerstones are innovation, material, sustainability, and technology. So with that, the reason why we chose to 3D print, I'm going to go really quickly over the whys and then talk to you about the hows. 3D printing is faster. The classroom we did was less than 18 hours to print. It is economically scalable. The first house might be expensive. The 100th would not be that expensive. Uh, Less labor. Uh, you can build more complex structures. You don't have to make formworks. It doesn't need to rest. It is a machine. It can print 24/7. It can be more sustainable. And we can look at how we want to evolve when it comes to workforce training. So we're going to talk about these two projects. We have some models here we'll dig into a bit later. Uh, One of the other reasons that we chose to 3D print is in Madagascar, east coast of Africa, there every year has been a cyclone. And so whatever they build gets torn down. And this school not only serves as a school, but as a shelter for the community during a cyclone. It serves for other activities after 5 o'clock to get the community together. So how technology can play a role, not just in sustainability, but bringing people together. I'm going to hand it over to Bruno to talk a little bit about to get into the process of 3D printing.
Hi, everyone. So 3D printing is but a fashion of the bigger question of automation and construction, right? So we're going to do a deep dive on 3D printing and just kind of see how it can handle big picture. What we're talking about is automating construction, which is a theme we've heard here today already, right? So some of the technology we're talking about here is on the left is the gantry system from Cobot in Denmark, which we used for the first pilot project. On the right, we have the crane system from WASP, which is from Italy. These two are actually printing with two different materials. On the right, that's clay composite, and on the left, that's concrete. And we've also have geopolymers as an option for printers. And we actually have metal printing, which is a sintering process, which is very expensive, but will soon drop in price. But conceptually, these are kind of some of the pieces that we have here. So how does this technology work, right? It's actually probably not that different than what you've already experienced in your own offices or elsewhere, where you have a material, maybe it's a spool in your desktop 3D printer. In our case, we have a bag of cement. Then we have a silo, which the material goes inside of, and we have a pump that mixes that in, right? We have a 3D file, an STL file that we feed into the machine, right? And then you press play, just like you would on your desktop 3D printer, goes to the crane or gantry system, and then we get our output, right? Our building, which in most cases right now are just walls. The wall typology is actually what was the most exciting piece of this initially, because it dropped down cost and created a less material for use and higher sustainability. The wall assembly consists of a couple different measurements that you have there for the wall thickness and the cavity, right? So you can get more insulation or less depending on what kind of wall type you need. So you can go all the way from, you know, your R19 typical and residential. We could go R30 if we just make that a little bit thicker. Your cost is very minimal. To all the way to R60, which we've seen Lake Flato do in Austin, Texas. And then in between, when you print like 10 layers high, maybe 30 inches off the ground, we have masonry ties. A lot of vendors are doing that. We actually don't think theoretically need them right now because it's a 9,000 PSI concrete, so compression rate, it's very strong. So we're adding those, some of these things we're adding because it's hard to get permitting right now. So we're using comps to other systems. You can also just print a single wall and you can just corrugate it just like you would if you're making your model, right? Your piece of paper on your chipboard doesn't stand straight, but if you corrugate it, it will. Same thing applies here. So a lot of techniques from simple model making can apply, right? So when all this stuff comes together, you can see kind of the wall typology. We have different masonry ties that pull the two pieces together. Sometimes you do 2 layers on the outside for a little bit more stability. A section of what that corrugation looks like. That's just a printing nozzle. We can, you know, you have your little corrugated pieces here, but we can get that flat as well. And then how systems integrate. So like I said, you put your masonry ties in or your wall ties or your binders or whatever you have between vendors at a certain height, and then you can actually come in and put your electrical boxes in and your plumbing as well. And think that this is all prefabricated already. More on that in a minute, but couple different ways to do that. And then we also introduce lintels and span plates, and that's how we bridge across because there's practically no tensile strength in this, right? So we use a lot of steel in between. And this wall typology here is from Icon, actually. Very little thermal bridging. You can see the concrete doesn't actually touch one another. And we have a big, thick layer of insulation in between. So really our bridging that we're seeing is an opening. So we have openings for doors, you know, your apertures, your windows. That have to be higher performing, but the wall is extremely high performing for very little cost. So we actually see that beyond walls, right? You can build the foundations with it. This image is actually in Florida. And then on the left over there, both these images, sets of images here in Florida, we can actually have ISF panels and steel studs to be able to build our floor plates and or roof planes, which are also insulated, right? And we have on the bottom left from Paris, the first 2-story 3D printed apartment complex, which was in Germany. And this system actually that they used builds about 45-ish feet to 75 feet deep to 3 stories tall. So, you know, we're getting close to commercial applications, but we're starting in the residential market for a reason based on size and certain technical limitations. But this brings us to the era of the digital twin for project deliverables, right? You know, for our project, we certainly did a full CD set. Just like we would for everything else. But as we were working through this process, we realized even for our model making here, that the 3DCP file, that's your STL, your digital file, was actually the most important and critical piece of the project. And what you're seeing there is actually the same file that I printed that we would see in here, right? This is the next project, but Same thing. I sent them the same file that I printed my plastic model in, and they printed that on site. And you can see that actually looks really close to what you guys probably use, your Curas, your MakerBot software, what have you, very similar. And it says 15-hour print time there. We achieved something very close on the job site. So that was the printed model that I printed at my office. And then this is actually radically transforming timelines as we see it in the project. And it's empowering the local workforce. So this is in Madagascar. We shipped out the shipping container full of material, and the second shipping container had the crane system inside of it. They hoisted it up in place. It's all aluminum, lightweight systems. That's what it looks like against the landscape, printing the first set of layers right there. On the right is the rendering. On the left is the printed project. And you can actually see the striation coloring of the start and stop of the printer. That's because they didn't print for 18 hours straight to build it. And then we're actually evolving that typology a little bit, where we're trying to integrate columns inside of it. So the wall type becomes a formwork, which we pour the column later. As we're still trying to figure out this technology, right? It's very new. We don't have structural buy-in for everything. There's no ICC, there's no IBC for this. There's no ASTM standards for it. We're all developing that real time. So we have some backup systems that we're doing here. And that's why we're printing formwork to pour columns into to rely on that structurally.
So I want to talk a couple of more pieces of innovation as technologies integrate together. This is how the sort of finished product looks like. And you can see there's literally nothing in the context around, but the ability to create space, getting kids together, it doesn't look very different from any typical construction campus, right? We've used two different things here. So one is, yes, you can print anything you want, any shape you want, but we've boiled down the whole project into 3 walls. And what it does is with the crane printer, it prints the first wall. This one is aluminum, so you can pick it up, put it, print again, print wall number 2. And each wall is crafted, optimized, scripted to use as less material as we can. So even if we save 20% on one wall, after a few walls, after 4 walls, you can have the 5th wall free. After 4 classrooms, you can get the 5th one. So it's more sustainable. This is the mock test printed in Italy. We were very excited. We're also working with a UK-based designer who is now figuring out how to print 3D beams and having a post-tension cable to it. The next part of this is, for a change to be optimistic, it's not about losing jobs. We are now training, as we are talking, someone in Madagascar is translating all the training videos into Malagasy and French, and the kids are introduced to these courses. Very happy to announce that our partner is paying off over 5 years for the printer cost, and the printer stays in Madagascar, is capable of printing with soil. So they have the material, they have the training, they have the machine. And now we empower them. We get local businesses, establish a pipeline of materials and so on. And technology is used to innovate and empower. And I keep coming back to it because I think it is super important for us to be mindful, be empathetic, and have a purpose to our innovation. So with that, you're all welcome to come collaborate and share technologies and have a discussion about how can we do things differently. Anything else you want to add, Bruno? Yes, I do want to thank Chicago Innovate again and Taruna as well. We are here, but we would not be here without her. So thank you all.